Okay, I think we'll get started. So today's lab with the LuckFox Pico Max is to connect it to 74HC4051 chip. And the 4051 chip is a neat way to extend the analog to digital capabilities of the LuckFox. So we know that the LuckFox has two A to D channels, and what the utilizing this chip does is it allows us to extend that to 8 channels. This chip is an analog 8-channel multiplexer. It's also a demultiplexer, but we're just going to talk about the multiplexer aspect of this. So what that means is that with 3 of the digital I/O pins, of which the LuckFox has plenty, we can select 1 of 8 input analog signals, and then that signal gets selected to be the one output analog signal coming from that chip that then goes into LuckFox, one of the 2 LuckFox analog to digital conversion pins. So very neat way to extend this utilizing the plentiful GPIO pins that the LuckFox has. Now, we're going to kind of have, this could be sort of in 2 parts, but all together in one video here. I'm going to go now to the data sheet, then we'll go to a particular circuit that kind of just walks through the use of this. Then we'll come back to the whiteboard and I won't say anything about this now, but I'll talk about just a simple application here with a bunch of photoresistors. All right, so let's go to the data sheet first and kind of get a feel for this this pin or this chip, and we'll see what it's all about. Okay, so this is a 16-pin chip. Let's see if I can show it here. We'll come to this in just a moment, but here it is in our circuit, which we'll get to in just a bit. But sitting right here, notches on top, so this is oriented this same way. Powered by VCC up in this upper right corner, which is pretty typical, and then ground in this lower left corner. A couple of other pins. This actually can receive a negative voltage, but this is usually, and it will be in our case, just tied to ground. So this will give us a range from VCC to 0 in our case, or to ground. Now, the other pin that is not sort of the ones we're all that interested in is this enable pin. So this is active low. That's indicated by the bar over the E there, and so this will also be tied to ground. So we're just going to tie all 3 of these pins to ground, and that will keep the chip active. Now, as we scan this, we see kind of, I'm not sure what the rhyme or reason, I don't think there is one here. The first channel and counts starting with 0, so it'll go 0 through 7 will be the 8 channels. So here's 0, 1, 2, 3. So 4 of the channels are over on this side, and then 4 and 5 kind of here, and then 6 and 7. So in the first circuit we're not going to really care which pin we're going to, but in the application we want to care about the order of this. So you really have to check the data sheet here to get the pin ordering. It's not in an obvious order. So that's the inputs, and then pin 3 here, that is the output. So only one of these 8 will come out at any given time, and it will come out pin 3. And that's determined by the selector pins. So this will be basically each one of these pins could be a 1 or a 0. So there's 3 of those. So in binary, that would allow us to count from 0 to 7. And that's exactly what we do here in terms of choosing the channel. So let's look at how that's done here in this part of the diagram, or this part of the data sheet. So this is on page 27. This one was very early on page 4, but then you have to get quite far down the data sheet to actually see the code, the selection code. But it is, unlike the order of the analog pins on the chip, it is in obvious order. So it just counts in binary right here from 0 to 7. So for example, if all the selector pins are held low, so if we tie all of the selector pins here, so all of these are connected to ground, then we will get channel 0 coming out. So then channel 0 will be coming out of pin 3. So whatever's going into channel 0 will just be coming out of channel 3, or the output here. And then 1 corresponds to 1, and 2 in binary corresponds to 2, and so on, all the way down to, if we're all high voltage, then we will be getting channel 7. So that is the data sheet. So what we'll do now is move to looking at the program and seeing how we expand what's going on here. Okay, first things first, let me just quickly show you the actual chip that we're using. So I'll switch here to show the DigiKey page where I got mine from. Very inexpensive, 72 cents here for an expansion of the analog to digital conversion capabilities of the LuckFox. Okay, so let's look at the circuit itself here, and I'll just start with this. And maybe I'll come in a little closer if I can. So a little bit of a mess here. So let me first just say what's going on down here. This is really not necessary. What I've got going on here is I want to have different voltages coming into the lines just for our demonstration here. And so I've made this put 5 of these 1K ohm resistors in series to produce these various stepped voltage dividers. So we can go from the full voltage of 5 volts down to 0. I've got a USB plugged in right here. These 2 lines are coming just to the wall charger from a USB. And so we're getting about 5.1 volts. And then roughly speaking, we're going to get a step down of voltage wherever we place our wire. So these 2, for example, are going to give the same voltage, and they're leading into, well, we can even see here, quickly go back to our sheet here. So coming down from the top, A2, A1, A0, A3. So up here, A2 is going directly to the rail line. So that should be coming in on A2, we should have the full 5 volts. Then you can kind of see this white wire underneath here. That's going to be coming in on A1. And so where's that coming from? That's coming from this junction here. So we should be reading about a voltage less, so about 4 volts there. Then these 2 are coming from this junction, so we should be approximately 3 volts there, and so on. So that's our setup for getting different voltages into our chip. The top, this is our VCC, so this is our power supply. The yellow here is the 5 volts, and then down here, this yellow is going to ground, and we see that's on the last pin here. And it's hard to see here. Let's see if I can point them out with the tip of this screwdriver. Is a jumper wire here and a jumper wire here. So these bottom 3 pins are connected, and we talked about that we're pulling the enable pin to ground because it's active low, and then our low voltage value will be equal to ground. This can be negative in certain situations. The chip can handle that, but we're not doing that here. Then finally, the other pins are going to be other inputs. Again, they'll be coming from our different parts of our voltage divider. And then pin 3 is our output. So pin 3 is this wire here. So now I'm going to expand back out, if I can here, so that we can see the LuckFox circuitry. So here's our wire that's coming from our output on our HC4051, and that's kind of going into some nonsense here too. Well, what's happening here? This is an issue we face with the LuckFox is its A to D can only range from 0 to 1.8. So we have to make a little voltage divider because we know our highest voltage over here is going to be about a little over 5 volts or 5 volts, and we'll read that directly on the meter here soon. So we'll bring that into here, and what we want is that to have a maximum of 1.8 volts. So we have this trim pot here that we can adjust so that our maximum voltage is 1.8 volts. Then the purple, or the brown, sorry, the brown here is the output of that, and so effectively this is the step down input coming from the HC4051, and that's going into analog to digital 0 on the LuckFox. So if you did the earlier video on just the straight analog to digital conversion that we did earlier in the series, we just pick up from there then. And so the role of this chip again then is to just allow us to select for that. Well, that's coming from these 3 pins just acting as GPIO pins. So make sure that the UART and the I2C and all that are turned off on those pins. And if you're set up as the way we've been going through this video, that should be all fine. So we've got just 3 open GPIO pins coming in to be S1, S0, S1, and S2 as our selector pins. So that's our setup here. Let me see if I can pull in the power meter or voltage meter so that you can see it. Okay, I guess I could move this a little. I could come down a bit. Okay. So we'll just check our input power. So this is our service power of 5.1 volts from the USB. So if I put my probe here, I'm getting output from so this we don't know what this is yet, but what selected pin is selected here yet, but this will be voltage coming in from the chip itself, and then I'm going to have to just clip here, and then this will be the stepped down voltage there. And so what we're seeing is that we're not quite rail to rail on the so this is going to be our highest voltage that we're going to be getting out. So almost the 5.1, but not quite. So what we can do is we can make a slight adjustment over here. I'm going to make a slight adjustment here so that that's closer, a little closer to 1.8. A little sensitive here. Not a huge deal. Maybe we want to go a little less because we will actually be receiving this voltage, and we peg out on the LuckFox. There. Okay, so that'll be good. Okay, so I will leave the power meter here. So this is what's going into our LuckFox as selected as we select the different pins. Okay, so let's go take a look at how we do that with the code. I'll move my camera over here just a bit. So let me close the DigiKey here. So as always, just go to Google and Google us here. So That'll be Darren Olness. And we'll click on this first one. And then under teaching, you can go LuckFox. And then we'll go all the way to the bottom here till we find the 74HC4051, the analog multiplexer. So let's click on that. Again, I saved these as, they're up here as text files, but they're really Python files. They're also on the GitHub page if you're getting them from there. Okay, so let's just grab this, copy that, and let's go to our terminal here, and let's just go sudo nano, what do we want to call this? 74HC4051. We'll call this just a test, let's say. So there's quite a bit of code here. I've been using Gemini 2.5 Pro. It's a great job. It does a good job of error handling, which I'm terrible at, but it does add some extra code, necessary code for good error handling. But we'll just kind of focus on what this is going to do. So basically here, what we want to do is just have the user select one of the pins, and this will be just a decimal input, so 0 through 7, and then display the voltage back out on the terminal. And meanwhile, we will look at the voltage over here on the multimeter. So let me copy this in, and so not too much is necessary here. Everything should be set up for you. And the pin selects, if you've been following through with the series so far, everything should work just fine. So essentially we have chosen pins 64, 65, and 66 and those are not the physical pin labels. Remember, those are the calculated pin labels and that the LuckFox uses for identification. So these are going to be our pins that we select. So I'll go back here, and if you can see my hand over here on the circuit, these three wires are coming from these three pins on the LuckFox. Then this is just the analog to digital stuff, so that should be fine as is. Then just some functions here for the pins. A little bit overkill what Gemini Pro does, but nice in terms of the error handling. Let me just come down here to the main program. So it'll just give some information that things are working okay at first. Then the user here will be asked, this is the main part here, the user will be asked to, not that there, let's see, enter right here, enter one of the channels on the multiplexer or a cue to quit. And so you'll have a chance to answer 0 to 7. Then this stuff is just to make sure that you answer between 0 and 7. It'll print out the voltage. So let's exit here. And so let's now go sudo Python 3 so that we can run our program. Everything runs here, just gives us our all systems go statements here. And then let's read in the voltage. So we saw that these, let me see if I can go back, and I know it's harder to see now because I'm backed out, but these two were going to pin 0 and pin 1. So they should give the same voltage. So let's try that. So pin 0, 0.665, right? And here we are there, right? So it's not where the conversion on the LuckFox isn't perfect, but definitely we can see that that it's working just fine. And you can adjust. If you needed to be very, very precise, what you would do is calibrate this against a good quality multimeter here. Okay, so let's try pin 1. This should, I think, be the same. Oh no, that's different. Yeah, pin 1. Oh right, pin 1 is different than pin 0 input over here. So this is about 0.99 volts. So if we were to go back over here on this side, so this is the voltage off the chip. It's about 2.5 volts off the chip. And then over here, we're getting our 1 volt here. Okay, so let's try pin 2. I think pin 2, yes, pin 2 was the higher voltage pin. So that is almost full scale. So we see 1.8, and this would round to 1.8 here. Pin 3, 0.66, pin 4, just make sure everything works here. 95 millivolts, 98 millivolts here. So that's almost 0 into pin 4. Pin 5, 303 millivolts. Where are we at? 6. 062. And so we're seeing that. And then 7, our last pin, 304, 308 millivolts. Okay, so this is sort of the basic usage of the HC, the 74HC4051. So now I'm going to go back to the whiteboard, and we'll talk about our little application here, where we'll be using all of these in tandem with some photo detection. Okay, so let's you do an application here. And so what we're going to do is we have all these analog inputs that we can select from, so 8 of them. And we're going to set up a voltage divider with a photoresistor and a regular resistor. And so as light shines on this photoresistor, changes its resistance and thereby changes the voltage across this resistor. So we will attach our photoresistors to the 5-volt rail and our regular resistors, which are going to be 1K resistors, to the ground. If we block this, then the resistance goes up. If this resistance goes up, then this voltage across this resistor is going to go down. So as we lose light level, our voltage will go down. And if we were to shine light on this, then the resistance goes down. So light level goes up, this resistance goes down, so then the voltage goes up across this resistor here. This will be fed in then to the 8 channels, as we mentioned. So pretty simple setup. We're going to space these out evenly. And then what we're going to do is we're going to use them to detect motion. So we're going to slide our hand across like this, casting a shadow. And then the LuckFox will report back to us, were we moving to the left or to the right. We'll also do it with the flashlight from our cell phones. So we'll run that across like this, and again see if it will report left or right. So the algorithm that I'm using here is pretty simple, and it's limited to how fast it can detect motion and that sort of thing. So it's not entirely super robust, but basically, we're going to do an initial scan for the values and of each of these. So it'll quickly scan through the LuckFox will quickly shift the S0, S1, and S2 pins from 0 through 7, record the voltage into an array, and those will be our background values. Note, of course, even though these are all the same, I got them from the same batch of photoresistors and the same batch of 1K resistors, there's a lot of variability here. And so the background voltage for each one of these ranges quite considerably. But all we need is the background, because then when we enter our loop, we're just going to continually go through this loop until we exit the program. It's going to calculate the absolute deviation from the background values. So if we're not doing anything, then each one of these will read essentially the same, and we'll calculate basically 0 for the delta V. But if we cast a shadow on one of them, then that will have a larger delta V. Or if we shine light on one of them, it'll have a larger delta V. So we're just taking the absolute value here. So it can't tell the difference between getting darker or getting lighter. It's just trying to tell the difference between compared to the ambient background. So I thought probably the best thing to do here would be to just calculate the center of mass of this, or the weighted average of this, and then as it steps through, it will compare that to the previous step. And if the weighted average has moved this direction, then we know that we're moving this direction with our shadow or our light. And if our weighted average has moved this direction, then we know we're moving this way. Now, of course, the timing of this loop is important. So we'll see that when we whip past, we won't be able to catch it. Or if we go too slow, we won't be able to catch it. Then it'll just simply report to the screen left or right. So a fun little program just to kind of get a sense of the usefulness of recording a whole bunch of analog signals. So let's go to the computer now and see how this all works. Okay, so here's the setup. Actually, let me do this. You start like this, so you see a little better view here. Everything's similar to what we had before, but now instead of that 5-piece voltage divider, we have 8 input lines, all these green wires, coming in from the resistor. This kind of turned around. Notice this is turned around. Here's the ground is up here and the 5-volt rail is down here. So it really does match what we saw on the screen, but I just flipped it around so I could reach the, well, I just flipped it around. So here are our photoresistors. We'll sweep our hand across, and notice there's a shadow that comes across, and that will work. Or we will use our cell phone here, and we will shine light across like this. Okay, so let's give that a go. So let me switch back now to where we can see the computer, and we'll go to our page, and right here, and then teaching LuckFox. Let's scroll all the way down, and our here, application, motion detection with the photo array. Again, this is it's saved as a text file, but it's really a Python file. You can also find this on GitHub. And again, I've been using Gemini 2.5, which does an excellent job. Although we did have to go back and forth a couple of times here. It didn't. All the other programs that we've been doing so far, or most of the other programs we've been doing so far, it's been able to get it right away. But this was a little bit trickier. So a couple of iterations with it worked really well. Okay, so copy this, and now we will go to our terminal, and let's go sudo nano 74HC4051 array.py, and we'll get into our text editor. Okay, got it in here. Fairly long program here, and I won't go through the details. Again, awful lot of very good error handling done by Gemini that I'm not good at, but same selector pins just like we had before, so very similar setup. Same, the A to D is all set up, and so I kind of went through that algorithm on the board there in more general sense. That's what's being carried out here with this program. So I won't say too much about it. If you want to look at it, try to follow the details, yeah, please do. But we'll just jump to the running of the program here. So we'll Control X this and then Y this to save. And then we will go sudo Python 3. Okay, apparently I had an incorrect copy here, so I will again pause the video, get that corrected. Sorry about that. Had a couple of extra lines copied there at the bottom that weren't necessary. So go ahead and rerun this, sudo nano. Okay, so here what we're seeing is our background. Oh, looks like, okay, I'm gonna have to, I think maybe one of the wires came loose here, but I think it'll still work. So notice this is, although they're different, they're not this different. So this is not reading much. So I think the wire came loose. All these are, see how they're roughly the same, but still quite a bit of variability. So this is background, and then we're going to be, it's looping right now. And so it's seeing, it's detecting nothing because the ambient, it's reading the same ambient voltage each time. So it's live and active. So let's go ahead and I'm just going to run my hand across. And notice, so what you want to be noticing when I do that is notice the bottom line here as I go across. And you can see it's reporting the position of the center of mass, and then it's reporting that I'm moving to the left. Now I'm going to go to the right. And it's reporting again, let me highlight that. It's reporting again that I'm going to the right. Now notice, if I go really fast, we get a little report sometimes, but we don't latch on and get the left to right. So we have to go kind of slow. And even there was a bit too fast, huh? Okay. All right. Let's try this with the light from my phone. So now we're getting more light. Oh, oh yeah, it's to the right. And my left and right mixed around. Again, I'll highlight this. So go again to the right. Okay, and then we'll move to the left. Notice if I just sit here, right, it goes away now because I'm not moving at all. So if I move very slowly, I can trick it. I'm sneaking up on it. It can't see me because it's comparing, when it compares to the previous run, I'm not moving fast enough. But if I go like that, then of course, didn't quite work there, but let's try it again. There it worked. Okay, so we did have this, let me see, that's number 6. So 7, channel 6 be this last one. Yeah, it looks like it came up a bit here. Let me push that down in, and we'll try to run the program again. Might still have trouble there. Not a big deal. So just quickly try to run it again. Yeah, still having trouble. So something's up with my connection here for pin number 6, but was able to work with a missing pixel there. So it still worked just fine. All right, so this is a good example, fun little example of utilizing a whole bunch of analog inputs. And the 74HC4051 is a great chip for doing that. Super inexpensive and really easy to set up with the LuckFox. Biggest thing, that's operating on the 5 volts, and you have to step that down into the 0 to 1.8 that works for the LuckFox. But other than that, an easy way to extend the capabilities of the LuckFox. All right, so that ends the lab for this chip.